As a result of climate change, by the year 2100, the entire seafloor will see a shift in a variety of stressors, including temperature. But there are a few red spots. Those were spots that were changing more drastically and more rapidly than anywhere else on the planet. And one of those is where we are right now. It came out as a bright red spot in the Chukchi Sea is one of those main areas where we will see a massive temperature increase as a result of climate change by the year 2100.
The system is changing now, and at this time of year, 3 or 4 decades ago, we would have seen a lot of sea ice.
It's just interesting how quickly things have changed, and sea ice drives the ecosystem and how that ecosystem functions over summer. And sea ice is really good for the ecosystem.
Arctic IERP has an overall goal of trying to understand how changes in the ice environment and other associated environmental changes impact the ecosystem now and how it will potentially impact it in the future. So this is an end-to-end ecosystem study, meaning that we're studying as much as we can from the physics and chemistry through the plankton, the very smallest animals, the bacteria and the microbes, to the fishes that swim in the water. And then we also have studies for marine mammals and seabirds. The focus of our cruises is the springtime period in particular, shortly after the ice has left the northern Bering Sea and southern Chukchi Sea, and we're interested in the spring bloom.
The spring bloom is actually this interesting phenomenon that happens in all oceans. And it is essentially in the spring, things green up. Once the sun comes up in the Arctic, of course we know that plants need sun, and they use that sun to produce oxygen. So you have phytoplankton, which are tiny little plants in the ocean. And these phytoplankton, in fact, provide us 50% of our oxygen. The sun hits the water, and then all the nutrients in the water that have been upwelled or shed down into the water column from the ice feeds the plants. And these plants grow. And the plants then feed zooplankton, which are tiny little animals, copepods, krill. You can think of them as another step in the food chain. And these zooplankton feed fish, and the fish feed bigger fish. And they feed humans. And whales also eat zooplankton, so it's really interesting that some of the biggest animals on the planet eat some of the smallest animals on the planet. And this whole spring bloom is bringing a lot of productivity to the Arctic.
By being early, we see these benthic organisms in a different state than when we see them in August, and that is in terms of reproduction. That is something you don't normally see, and so being able to pinpoint the timing of these events more is important to understand the dynamics of the system.
It's really important to study the Arctic at all times of year, but especially in the spring and summer, because the spring is essentially when things are opening up and changing. In the northern Bering Strait region, it's when the sea ice moves and animals start migrating north. The IERP gave us the opportunity to be there in June and July and throughout the summer, which was incredibly valuable. So the results of this IERP project, I think, are really interesting in that we just happened to be there at a time of additional rapid change. So 2017 and 2018 were exceptional years in the Arctic, but record-breaking in terms of heat in the water, less sea ice, more wind. You can't measure baseline data if the baseline is constantly shifting.
Getting an understanding of what happens in the ecosystem in the Arctic, you really need to understand the dynamics of the spring bloom, how that sets up summer productivity, and what that means in terms of fish fitness. And that means this holistic view that we had here for the Arctic IERP was the spring survey, where you've got an indication of how the ecosystem is going to set up for summer. And then our late summer surveys where we go out and we see how the ecosystem has actually played out in terms of fish fitness, how fat fish got, which is really important because the amount of fat that fish get over summer helps them survive winter. When we ran our Arctic IERP program and we went out there in 2017, things begin to change pretty rapidly. Some of those changes were adult Pacific cod moving into the northern Bering Sea. It was a rapid change and a rapid shift in fish distribution and commercial fisheries. This is something that none of us expected to see. And so the Arctic IERP research that we conducted did change the way I thought about the Arctic. The notion that you have Arctic cod that are in the Chukchi and that are subarctic are down in the Bering Sea is something that we didn't think we would see change for quite some time. And just to start seeing young walleye pollock in the southern Chukchi Sea during 2017, and then a full-scale movement of young walleye pollock up into the Chukchi in 2019 is something that really surprised all of us.
NPRB is really excited about the model we've developed with the IERP program. In the future, we plan to continue our integrated research in the Bering and Chukchi Seas and really hone in on that northern Bering Sea region where we're seeing some very rapid change.
One of the reasons I love my job is that as an oceanographer, you get to work with amazing people. It's working with physics, chemists, biologists, and geologists to understand how an entire ocean works. Water moves chemistry, water moves biology, and all of this together interacts to actually make an ocean ecosystem. And so going out on a cruise like this, you can actually study the ecosystem, not just a small component of it. When you add into that, you get more of a holistic view of a place like the Arctic than you could do if you ever came out with a very specialized team that only wanted to look at one particular aspect of the ecosystem.
There are communities there that rely on this ecosystem for their food security, and they've been there for thousands of years, and so we need to be listening more to what their interests and their needs are. These IERPs have just been instrumental in us understanding how climate's impacting large marine ecosystems in Alaska.
You can't do that without understanding what are the inputs to basically making fish, and that starts with phytoplankton and understanding the food web and being able to predict how that might be in the future, whether that's something simple like how storms influence the success of fish, or bigger questions are really how climate change and how changes in the ice timing and thickness will impact the entire ecosystem. So whether that means new organisms being able to move in because it's warmer, different types of organisms happening because they're not associated with the ice, or just the different timing of the ecosystem, which are all big changes that are happening here. And it's happening here faster than it is anywhere else on Earth.
Waters in the Arctic ecosystem are predicted to be warmer on average in the future than they have been in the past. So the Arctic IERP set out to measure rates of growth, reproduction, fat storage of animals in the Arctic ecosystem under different temperature conditions to help us understand how the ecosystem might respond to future conditions. And we were really shocked when we went out and sampled in 2017, 2018, and 2019, and we found water temperatures were at levels that we weren't predicted to hit until 2050. So we had a really unique opportunity to study the future Arctic. What we were able to do with the integrated ecosystem research approach was we collected information on everything from ocean physics and chemistry to every aspect of the biology, and then we were able to look at the linkages from the physics to the biology to really understand why we were seeing the dramatic changes that we were seeing. And what we hope that will allow us to do then is to build better informed ecological models so that we can better predict what those average conditions may be in the future once climate warms to that point. From the beginning, the Arctic IERP set out to study the Arctic ecosystem from top to bottom to provide information that's relevant to the people that are living in the Arctic. We really wanted the research products to become tools in the hands of resilient communities.